This is part 3 of our lesson of completing the square. It took us a long time to get through the first example, but I think once you've done it and you've figured out all the steps to follow, it goes a little faster every time you do it. So this one says, write the following in vertex form, state the transformations. So I have y equals negative 3x squared minus 6x plus 9. So in the last part we discussed how you need to complete the square to make this into vertex form. This currently is called standard form. To get it into vertex form, you need to complete the square. So step 1 in completing the square was to group together everything that has an x. And then we're going to factor out whatever the coefficient of the x squared is that's there. So I'm going to factor out a 3. That's going to leave me with x squared. And then negative 3 times what gives me negative 6? Negative 3 times positive 2 gives me negative 6. You want to resist the temptation to take out that x. You only take out the coefficient. And then 19. All right, so what I want is I want this to factor. So I want to stretch it out into 3 terms that will factor. So I have x squared plus 2x, and then I want to stretch that bracket out so that I can make it so that it's factorable. Leave that plus 19 on the end. So normally we would multiply the first and last term and look for something that multiplied to that and adds to the middle. Except I don't know what it's going to multiply to, but I do know that it is going to add to 2. So what we want to do is find 2 numbers that add to 2, and I want them to be the same 2 numbers that add to 2. So 1 plus 1 would give me 2. If you're not sure what the numbers are, you can take 2 and divide it by 2. That's an easy little shortcut that you can use. 1 times 1 is 1. So that's my magic number right there, that number 1. So into the bracket, we're going to add 1, and that's the trinomial that we want to be able to factor. But the problem is if I add the 1, I've changed the question. So what we need to do is cancel it back out by subtracting a 1. So the x squared plus 2x plus 1 is what I want inside that bracket. That negative 1 really needs to go. But in order to get it out, we do need to multiply by negative 3 to make that happen, to FOIL it out of the bracket. So I have negative 3. We're leaving the x squared, the 2x, and the 1 inside the bracket. And then we're going to multiply out negative 3 times negative 1 is positive 3 plus 19. I'm going to simplify these terms here. 3 plus 19 is 22. And then our last step is to take this and factor it. I like to factor it over on the side. So I have x squared plus 2x plus 1. And I'm looking for 2 numbers that multiply to 1 and add to 2. Now the convenient thing is we've already found those 2 numbers. They are 1 and 1. So it makes our lives a little easier here that I can just throw the 1 and 1 in there. And then we're going to group. Take an x out of the first one. We're left with x plus 1. Take a 1 out of the second one. We're left with x plus 1. So this is x plus 1 times x plus 1, which is the same thing as x plus 1 squared. So here I'm going to take out the x squared plus 2x plus 1, and in its place we're going to put in x plus 1 squared. And that's it. That's in completed square form. Now the question did say that I want to write the transformations. So I always like to start with this one here. The plus 22 is going to move the graph up 2. The plus 1 inside the bracket looks like it should go to the right. It actually goes the other way. It goes to the left. 1. And this one up front actually has 2 jobs. It is negative and it has a 3. So the negative is a reflection. And it's also a stretch of 3. So it's up 2, left 1, reflection, and a stretch of 3. All right, there's one more question here, which is to graph using transformations. It's good practice. So you'll notice, first of all, it's not in the right form for doing transformations, which means we need to complete the square. So I'm going to start by grouping together everything that has an x, and I'm going to take out what's in front of the x squared. Now, what's in front of the x squared is a negative sign. It's actually a negative 1. Negative 1 times what gives me positive 8? Negative 8. So negative 1 times x squared minus 8x minus 10. I want to stretch this out into something that will factor. And I need to look for two numbers that multiply to something and add to negative 8. And they need to be the same two numbers. So you can just divide this by 2, or you can think it out. But it should be negative 4 and negative 4. And negative 4 times negative 4 is going to give me positive 16. So our magic number here is 16. So I'm going to add 16. But the problem is that, unfortunately, I can't just add 16. It changes the question. So we also need to cancel out what we've done and subtract 16, even though it's not supposed to be part of that bracket. To get it out of the bracket, we're going to multiply it out by doing negative 1 times negative 16 to bounce it out of the bracket. And I have negative 1 times x squared minus 8x plus 16. Negative 1 times negative 16 is positive 16 minus 10. Just collect your like terms out here. Positive 16 minus 10 is 6. And then I need to factor x squared minus 8x plus 16. Put that down here. So I need two numbers that multiply to 16 and add to negative 8. And they are these numbers that we've already found, negative 4 and negative 4. So x squared minus 4x minus 4x plus 16. I can group. And then the first pair, they have an x in common. And I'm left with x minus 4. The second pair has a 4 in common. And we're left with x minus 4. So we end up, when we common factor, with x minus 4 times x minus 4, which is, oh, you can't see that, x minus 4 squared. So I'm going to replace and put negative 1, x minus 4 squared plus 6. So it did ask me to graph using transformations. So the first thing I'm going to do is list all the transformations. That plus 6 means my parabola is moving up 6. The negative 4 means we're moving right 4. And that negative 1 means that the graph is going to be upside down. It's a reflection. So to graph this, we start by doing the vertex first. Normally, the parabola x squared starts at 0, 0. This is going right 4, 1, 2, 3, 4, and up 6, 1, 2, 3, 4, 5, 6, and that's where the vertex is. Now there is a step pattern we normally use. We go by odd numbers, so 1, 3, 5, 7, 9. Because it's a reflection, instead of going up 1, 3, 5, 7, 9, we're actually going to go down 1, 3, 5, 7, and 9. So starting at the vertex, we're going to go down 1 and over 1, down 3 and over 1, down 5 and over 1, always over 1, and then down 7, which actually just fits. And then we do the same on the opposite side. So down 1, 3, 5, and 7. And then we want to draw in the parabola. I find it easier if I turn my page around. It should look curvy. You're not just connecting the dots, you're drawing a nice smooth curve. You need to go all the way to the end of the graph. And you need to put arrows on the end of your graph. And that's our parabola.